Just like that. So that's looking pretty good. So if you just joined us or you're watching on YouTube, howdy. I'm a 3D artist visualizer. I'm just kind of modeling a client project, and as you can see, we're building a kind of, it's like a beam engine, like a Victorian steam engine. So let's get back into it. So I'm just extruding out this arm. If you can see the reference, you'll notice there's a tiny little lip just here where kind of the cast iron reduces down into the longer component. So let's just get that out. Okay, and just pull that down. You don't need to do an actual extrude on that. Just as you can see, just use the gizmo and stop pulling whenever you want to create a join. So for example, we're about to make this thicker. You want to stop the extrude wherever you can predict that you're going to want to have a curve, part of the part of the bend. So as you can see here, we're just going to select that bit. I did that a bit lazily. Just pull these out and just really simply box model it. There's no point in using NURBS or anything fancy for something like this. This is intended to be a game asset, so we need it optimized, and trying to do this with anything other than box, it's not going to end well. So let's just keep doing that, and I'm constantly referring to the reference. On the next stream, I might have a photo of the reference to hand, just on the screen, so you can follow along better. Maybe, I don't know if that's something you guys want. Let me know in chat. Just getting a question here. Yeah, so yeah, basically, yeah. So selecting the sides there, and what we're going to do, we're just going to do an inner extrude, just because we want to kind of get that bevel in, which the ironwork has. Push that in, and we're done. Cool. Okay, so that was a pretty simple component. Let's hope the next one is as simple. So next component is the flywheel. Right. This isn't going to be simple. So first thing we're going to do is we're going to make a circle with a cylinder. Let's just say 0 height segments, and let's give it, I think 64 will do. So let's just thin that out. We're going to use symmetry on this, so just bear in mind if you're following along or if you're just watching. I'm going to apply symmetry onto this once I've completed this stage of the model, just, you know, so that we can have the same look from both sides. Let's go back and let's select the inner extrude. Just going to do a loop selection here and try and bridge it. Doesn't seem to want to bridge. That's always fun. So when bridge acts up like that, the best thing to do is try and get inside the model and actually try and isolate a single edge, because that's how bridge works. It follows an edge. So let's just come out here, and now what I'm going to do is I'm going to create the kind of embedded bevel aspect of this iron joint, and you can instantly see, if you have any experience with 3D, that this is going to be hard because it's on a curve. So what I'm going to do is I'm going to use Boolean, and you'll see what I mean momentarily. So let's just select every so many of these. I think that's looking about right. That's about 14, 15. Yeah. Okay, so this is going to be our gaps between the bevel. Okay. So what I'm going to do now is we're going to delete those gaps, so that all we're left with is, notice how I made a copy, by the way, because we want the original rim still. So this is an extra mesh. So I've made gaps where there isn't going to be a bevel. So this is going to be our Boolean mask, essentially. We're going to turn this into our Boolean that we're going to integrate with the base model, and that's going to give us our detail. So I just need to fill these ends in, because we all know how fussy Boolean is if you don't fill in the ends. So let's just do that. I'm just doing MB for bridge tool here. In future videos, I am going to use a on-screen display showing what keys I'm pressing, because I realise it can be a little bit difficult to follow if I'm working quite fast. So we're just going to select those edges. No, probably how I was doing it originally, isn't it? um, yeah. So we're just going to select those edges, and can be a bit fiddly. There we go. Just 1, 2, 3, 4. So hopefully by now you can kind of see what I'm doing. I'm gonna curve the edges of this frame. These are going to become kind of our ovals, and then we're going to integrate this into the kind of base cylinder. And this is a use case for Boolean, which you don't really see often. Is for, kind of detail. Most of the time I see Booleans used for making holes or extracts or unifying two models. There we go, that will do. Just make sure you don't have too many edges on that, by the way. So you'll notice I only used, I think it was 3 or 4 polygons on there. Yeah, you don't see it used this way often, so I think it's quite novel, which is why I'm showing it on this stream. So let's bring the original mesh back in. There we go, and let's lift up what we've just done. Okay, so this is the invert of what we want, and also you'll notice it's the same size as the base cylinder. That's not what we want. We want it to be slightly smaller. Well, in order to do that, we need to actually make this 2D. Because as you can see, yeah, it's not going to work. We're just going to scale it incorrectly to the curve if we try doing it like that. So what I'm going to do instead is I'm going to select the top of all of these curves and do an inner extrude and make it 2D. So let's just go back on that a second. And let's go to side view and let's select all of those tops. And let's go invert and let's delete everything that's left. Okay, so we're 2D. So next thing you want to do is yeah, just do a edge selection. So it's really good fun kind of narrating this alongside doing it, because I'm kind of telling myself not to do things at the same time. So yeah, we need to just get an inner extrude on all of those, and then you go invert, get rid of the edge that you've just deleted, like so. Bang. Good. Okay. Now, it's important to mention at this point, I did mention it earlier, but for those who have joined on YouTube, this isn't an exact art. This isn't CAD modeling. This is CG modeling. Okay, this is for a game. I'm using several different separate references for this model. So we just need to extrude that and we're done. So none of this is in exact art. I'm not using dimensions. I'm not using, I think this is like 2 meters wide or something when it's 10 meters in real life. It doesn't matter. As long as things are relative to each other correct, it just, scale doesn't matter. Obviously in the final model it will when we come to doing texturing and substance design especially, but right now it doesn't matter. So let's just ignore the fact that I've completely eyeballed that and put that in a Boolean. So you're combining your base mesh with your Boolean you've just made. Why doesn't that work? That's interesting. Okay. I'm going to leave this here. We're going to go back. Right, okay, yeah, I think I see what's happening. So this is the problem with Boolean. Sometimes it'll just get confused where the edge of the edge is on whatever you're trying to integrate into it. So yeah, as you can see, this hasn't worked, which is fine. I know how to fix this, but it's this is what puts people off using Boolean. It's very temperamental. If you've got just one overlapping poly or you've got a gap between 2 points, this kind of thing will always happen. So I'm kind of glad that happened while I'm on stream trying to demonstrate Boolean. So let's go back. Let's delete what we've just done. Let's lift that out slightly, and let's reintroduce Boolean. Okay, so that looks about right, and let's go subtract again. Yeah, it's fine. So just a bit of movement, bit of fiddling, and it works. I'm probably going to do an actual course on Boolean soon, just because I think it's one of the most misunderstood tools in Cinema 4D. But for the sake of this stream, for the sake of now, that works. That's great. Perfect. Okay, so the next thing we want to do, actually, yeah, that's a good point. Let's just make a copy of any generators that we use in this project, because you don't want to get 6 steps down the line and then realize, oh, there's something wrong with the Boole and I can't go back. So just make a copy of the raw object and then obviously condense it down into a mesh. So I want to get a bevel on these edges. I already know what's going to happen. Can you guess what's going to happen? Chat, do you know what's going to happen? Yeah. It's not going to work, because a Boolean is essentially adding a new object into the mesh. It's not part of the mesh, so you have to optimize it. So I'm going up to command here, pressing optimize, hit enter. Now it should work. There we go. Because it actually understands where that edge is. We didn't have a real edge before. Again, this is kind of where I need to explain Boolean better, but for the sake of this, just know that using optimize will 9 times out of 10 really help. Always optimize any generator that you use would be my advice. So let's look in Octane. That's looking pretty good. Just see how smooth the surfaces are. Make sure there's no overlapping polys, because Octane loves highlighting those, which is good. So what we want to see our mistakes. Let's rotate that 90 degrees. Cool. Okay, we have half a flywheel. Well, we have half a flywheel rim. There's plenty yet. So, yes. So our next stage is to put these kind of expansion joints. I don't know what they're called, I'm afraid. These joints between the iron details. So don't go making a hole in your model. There's no need. We're just going to fake it. I could even texture this, but I'm being lazy. I don't want to spend ages in Substance Painter adding this when it's only like 16 polys I'm adding. It's not worth it. That's when optimization goes too far. So let's go loop tool. And we're just going to extrude that in and done. And it's good that it's kind of random as well. I've intentionally not measured that. Just it makes it feel more organic. It makes it feel more realistic. Like this is an engine that's been working for 100 years or whatever. Let's have different gaps between the gaps, if that makes sense. So let's just bring that in. Fine, that's great. Fine. So once you render that out, that you're going to be able to tell that there's a quote unquote gap there. Easy. Really basic little thing for this kind of modelling, but it's something a lot of people ignore and try and overcomplicate. So we don't have enough polys in this rim for this to be a high quality model, I've just noticed, which is unfortunate, but it doesn't really bother me. But I am going to give it a lip around the edge just to kind of increase that definition. Otherwise, we are going to fall into uncanny valley and have very sharp edges everywhere on this. So I'm just going to bring that out a little bit. We're just going to use Gizmo Extrude, like so. Do I need a bevel on that? I don't think I need a bevel on that. No. Cool. Okay, so we've obviously got 64 polys here. I would probably actually going back do it in 128, but it's really not a problem. This is fine. It's more optimized this way. It looks good in the render view. You know, why fuss? So let's add a few rivets. If you look at the reference, it looks like there's a few kind of little rivets kind of dotted about the place. So we're just going to throw those in. So this is just a sphere object, just a primitive object. Just going to drag him in. I'm sure we all know how to use primitive objects if we're watching this course. It's not really a course, is it? It's more a standalone stream, but I'm hoping it will become a course. Cool. So obviously this is a bit wrong. Like we've got an entire sphere and we can only see half of it. That's just bad optimization. So let's go into wireframe and delete half of that sphere. I don't know, I might just be a bit OCD when it comes to optimization, but I don't like leaving things like that. I'm probably quite niche, and in some cases you don't want to do that, because the way that I've just cut that sphere, for example, some game engines won't be able to backface Colac correctly now. The reason why I'm confident I can do it here is because I've done it before. I know it works in most engines, but usually you do want to close your objects if you can. Okay, just rotate and copy and bring them over. It's amazing. It always amazes me anyway. The difference, like a little bit of detail can make, because this is just a ring with some random holes in it, but now we're putting these rivets in. It's like, oh, okay, it's a piece of machinery. It's functional. It does something. I always feel like with visualizations, the second you get the plants in, it just looks and feels so much better. Okay, cool. So, just for the sake of argument, this is why we're going to use symmetry. Just because I'm a bit off center here. We could do it this way. There's nothing wrong with doing it this way. We still need to do the sign writing though, so I'm not going to do it yet. Actually, we still have a lot of things to do before I can do this. But yeah, that's why we're using symmetry. It's cleaner. It's easier. You don't have broken joints everywhere. Okay, let's add a MoGraph text object, and what are we going to write? Something appropriate. Let's just say RNH. Let's say RNH Brothers Farmer. That sounds period. Lovely. Cool. Okay, so how the hell do we get this onto that curve? Well, I'm going to show you. I hope. No, so it's easy enough. All you need to do is chuck it into a bend deformer and then extrude it out. You've probably seen this or done this multiple times before, but for those of you who haven't, this is how you do it. Just get that size right. I think scale is going to be everything with selling this. We also need a bit more kind of rounded font, something that's going to look good in bold, I think. Tahoma might do it. Or Verdana. Yeah, Tahoma. That's a bit better. It doesn't have to be perfect at this point. Cool. Okay. Let's get this in. So let's introduce a bend. So it's important to note that you always need to make the text a parent. Easy mistake to fall into. I do it constantly because obviously you've got certain other things such as cloner which work in the opposite direction in Cinema 4D. But generators always work with the parent as the object to be manipulated. So let's just add the bend, let's rotate it the correct direction, let's apply the strength. That's another thing that I've noticed throws people, is the fact it will always default in a weird direction. I don't know why they still have that, but it does. So you just need to rotate the bend itself as opposed to the text. The text here is just the thing being manipulated by the deformer. Cool. Okay. That looks good. Let's... That might do it. Let's just give that all caps, because the Victorians like their capital letters. I think it was easier to cast or something, maybe. I don't know. Okay, cool. Yeah, so that's a bit off center, and I also don't like that curve, so we're just going to fiddle with that. Don't ever let anyone tell you that that you shouldn't fiddle, because I think most of 3D is fiddling, unless you're working, like, I don't know, on a visualization to a deadline. There's nothing wrong with fiddling. It's when you get the best results and learn the most things. Okay, that looks good to me. Will it do? Will it do? I don't know. There's something... I think the curve is slightly too strong on the end. Yeah, there we go. I think part of the reason this doesn't entirely look correct at the moment is because we can see the wireframe, and the wireframe is giving us the illusion that we have straight edges, because obviously we do have straight edges. I guess it isn't an illusion, is it? But once this is rendered and textured, you're not going to notice that. So I think that looks fine. It's always worth bearing in mind how things will look different without a wireframe overlay on them, because it's such an easy trap to fall into. It's trying to make something pretty with an overlay. and then you come to render it and it's not there, which is why it's good to have Octane in the corner like I do. Okay, so text, let's extrude you. Okay, let's make you 2 centimeters. That will definitely work. Don't want to over bake that. Just kind of hover it over the surface. Again, if we were working in CAD or BIM, this is absolutely no how I'm applying this stuff. But for the sake of CG, for the sake of stuff intersecting with other stuff, this is fine. This is fine for now. If Unreal Engine throws it out and says this can't be intersecting, then it's an easy fix. I should probably be snapping though. But let's change this angle. So that's a really helpful tip actually, which took me a while to figure out. Everything which is generated from splines, including MoGraph splines like this one, is affected by the angle. And this is a really good way to optimize things. As you can see, there's barely any polys there. Okay, that could have been so high poly. That could have been millions of polys, but I've made it like 500 polys. Yeah, just really crucial little stage, which everyone seems to miss out, is change the angle of the spline. And because we changed the angle, it's also much easier, as you can see, to get bevels working. Because we all know how much fun it can be to get bevels working on curvaceous objects sometimes. So the next thing I want to talk about is well, actually, I think we're there. No, maybe we're not actually. Is the fact that an object like this, we need to kind of look at the reference. We need to look at how it looks in the real world. So you'll notice straight away that the text doesn't quite look right in my model, and that's because it doesn't have layers of paint on it, basically. This is probably how the casting looked on the ironwork, but I promise you this isn't how it looks in real life now. So we're going to change the font, I think, and we're also going to make this bold. And this is just, this kind of talks into what I was saying earlier about always make it about the subject. Don't make it about the model. Make it about the thing that exists in real life. Don't make a model to be pretty. Make a model that's realistic, because ultimately when you get that into a game engine, it's going to look better in the context with other things. On its own, it might not look amazing, although usually it should. But always go back to the reference. The reference is key. Like, even if what you're designing is completely fictional and you don't have a reference, use a bloody reference. Let's say you're... I mean, everything has a reference these days. Let's say you're doing a completely alien planet. There's going to be a million sci-fi references, No Man's Sky, you name it. So, you know, just be keen on the references and don't be scared of copying, because that's what we're all doing. We're copying the real world. I'm withering now, so that's looking really good. I'm happy with that. I think once I get that into Substance Painter, that's going to look really, really cool. Just need to dupe that down here. Probably need something weird done to it, like different curve, although it shouldn't. Let's just... And again, you'll notice how I'm not snapping or being precise with this. Honestly, it will look better for it. Machinery, you have a slightly less liberty, I'll give you that. So with this, for example, I've got to be a bit more accurate than I would be with, I don't know, a forest or a wood cabin. But I can still be pretty audacious with this. So, that was a word, wasn't it? Audacious. Audacious. My audacity. Okay, so now we have our basic ring. This is essentially the outside of the flywheel, and it's not really the meat and potatoes. We still have all of this lovely detail to add here. So we've got spokes, we've got shaft going through the middle, and then everything else will just kind of hang off those. So a really good way of kind of deconstructing these historical objects, especially when it comes to stuff like architecture and engines, is you look at the skeleton, you think, okay, what's the basic elements which makes this what it is? And yeah, in this case it's these spokes and it's going to be this axle, and then we can have a look at everything else later. So let's jump into it. Right, so let's do the spokes. There's two principal ways we can do this. I mean, as with everything in 3D, there's 100 ways we can do everything. But the most obvious way is to select one of these quite conveniently shaped polys and extrude, inner extrude, extrude, inner extrude, and we have spokes, and they're all going to meet in the middle because that's how geometry works, and it's going to be happy days. The problem with this approach, there's two problems with this approach. The first is we're getting dangerously close to over meshing ourselves. I don't know if that's an actual word. I think it's a piece of terminology I've invented, but essentially what I mean by that is we don't want everything, all the components, to be part of the same object. You want to try and split out objects as much as possible just because it aids future iteration. Which is why the other way of doing it is better, cloner. The other reason cloner is better is you can make it more regular, you have a lot more control, and crucially, everything is linked back to a single model. So if ever you want to use cloner, a good kind of, I guess a good way of deciding whether to use cloner or another strategy is, will you want to iterate the single object after? If the answer is yes, then use cloner. It's that simple. So we're going to go radial, but obviously we haven't got anything to feed into the cloner yet. But we're going to give it the basic details. This wheel has 8 spokes. I have no idea what the radius is going to need to be yet, because I'm not working to DIMS on this project. I'm working to plans. Bit more on that later. And so I'm just putting an arbitrary figure in, and let's make a spoke. So again, scale doesn't really matter as long as you're following the reference. Yeah, scale only matters if you are working to something which is real world and you have a use case such as I don't know, projection mapping or something in the real world. Otherwise, you can sort scale out later. This probably sounds like a really stupid lesson to learn because we're all told that scale is the most important thing in 3D, but we just need to make sure everything is correct relative to itself. We don't need to make sure this is X meters long. In fact, I think this is only 2 meters long. In real life, it's probably 7 meters long. You know, we just need to know roughly what we're working with. So I've got kind of the central fin of that spoke, and if we look carefully at these spokes, they're interesting. I think they're just 2 beams intersecting as such. And the really interesting thing about Victorian engineering is you can almost always predict exactly how things are going to taper, just because of how things were built back then, really. So we have more strength at the base, makes sense, and the photo corroborates. There's definitely more room at the top to make this look a bit stronger though. Actually, do you know what? I'm going to give that a cap. So we're going to introduce a clean cube, and we're going to put him at the top. I'm not copying the reference for this bit. I'm just kind of eyeballing it, seeing what works the best. Although it does look like there's a cap up there somewhere. Just notice that's off center too. And we will be checking how many of these there are in a bit. It's also surprisingly nerve-wracking doing this on a stream. I'm sure I'll get used to it, but definitely feels like I've got an audience. So let's just make sure that's pretty close, which is a good thing. I'm not complaining about having an audience. Yeah, so that looks good to me. Let's bring him up. So the first thing you're going to notice is we've got a flat plane pushing up against a curve. It doesn't matter. We can push him in there, and no one's any the wiser. Yep. So I would say that's a pretty successful looking spoke. That's definitely placed wrong, but this is definitely a circle. So we throw it into a radial cloner and we should be able to do something. Okay, so as per usual, cloner has decided that it's going to do its own thing. So we're just going to expand that. There's a lot of ways to use cloner, so I'm not going to try preaching any particular way here. Everyone has their own way, but what you're seeing here is just kind of how I go about doing this kind of thing. Just because, really. So that's going to be -90. And then we can start fiddling with exactly how we're going to do that. So I can already tell I've made it too long, or have I? No, I might have nailed that actually. Perfect. Okay, that worked better than I expected. Cloner can be hit or miss. Getting some funkiness there. Is that? Yeah, okay, so I've just put that off center. See, I want this to kind of be a trademark of my tutorials, the fact that I do make mistakes. Not just because it is the best way to learn, but I think it's important to see how many mistakes people actually make in modeling, because we all make a lot of mistakes, especially ones when it comes to stuff like cloner. Okay, so I would actually say that's looking pretty good. Yeah, I would say that's done. So let's save that, because that's a kind of major stage done. So now we want to move on to the axle. I don't know if that's the correct word for it, but it definitely looks like one. It doesn't look too involved. So we've just got short bit, slightly bigger bit, flanged out, and then I'm guessing that's symmetrical on the other side. So let's have a look. It's worth bearing in mind that this is going to have to connect to this arm on the other side. So there might be something more involved there, but this is just the flywheel I'm doing at the moment, so let's focus on that. Cool. Right, so bring a cylinder in, get him turned around. Oh, I am doing that awkwardly. So for the scale of the axle, I'm going to say it's about there. For the scale of the length, of the scale, don't need any subdivs, or I don't want any subdivs, and 16 is a bit excessive. No, 16 is good. So this is kind of how you have to think when you're making models for, I don't know, distribution or CG. You always have to just be one step ahead of optimization. You have to know how many polys are on something without needing to look. I mean, I've got it up here, but I never use it. I don't guess, but I don't really need to look at it, just because it should become kind of a second nature thing over time. So we're going to make that nice and rounded. Maybe not that rounded though. Yeah, that's good. Looks more engineering-y. And we're just going to give that some slight curving, just so you know it looks like cast iron. Cool. Okay, so let's actually not care about that. So that's one side of the axle.